Welcome to my channel. In this session I am going to explain you about 2017 regulation EC8395 communication engineering question paper. So this regulation is only from 2017. So only one set of people has written this exam and only 2 questions are available, and so those questions are discussed here. So under first unit they have asked SSB generation using filter and phasing method. So either you can write that is any of the phase shift method, either Weaver's method or filters method. So under filter method one type, and here we have 2 types, so you can write any one method here. So the mark is only 8 marks. So you go with the block diagram and write about the generation in a short. So 8 marks you should write at least 3 pages. So 3 pages in the sense I am telling this one page, and here this one is the next page, and this one is the next page. So it comprises of 3 pages. It should comprise of 3 pages at least. Next is about compare AM with narrowband FM with respect to phasor diagram and expression. So they are asked to compare AM with FM. You can write any of the comparison, but the first 2 points should be like this. You should write the expression for AM, you should write the expression for narrowband FM, and you should draw the phasor diagram for AM and phasor diagram for FM. Then remaining 3 points. So each point carries 1 mark, and you should go with single point for each of this. So you can write in terms of bandwidth, you can write in terms of sidebands, and you can write in terms of expressions also. So this is how you go at least 5 points. Since there is 5 marks, you can write at least 5 points. If it is 8 marks, you should write at least 8 points. So confidently if you know 10 points, you can go for 10 points when it is asked for 8 marks. Here I am asking you to write at least 5 points. And the next question is that is, it is either or choice. In the first half they have asked these 2 questions combinedly 13 marks, and next choice is AM expression based on the spectrum phasor diagram with the AM diagram, that is AM derivation part, which is comprising of these 3 signals. That is, you will have a carrier, that is lower sideband and upper sideband representation. This is the AM expression equation, and you should draw the spectrum of the same. Spectrum in the sense bandwidth, and a phasor diagram in the sense which is having the carrier and lower sideband and upper sideband representation. Then you should draw the AM representation of carrier as well as the lower sideband as message signal and the carrier signal and representation of the same. So this diagram is nothing but you should draw the message, you should draw the carrier, and you should draw this shape of AM signal. That is what they have mentioned, and this is asked for 13 marks. So one small hint here is whenever they are asking for a split up question, avoid those split up question unless you don't know the other case. Go with the choice of full 13 mark question possibly. It will give you more marks. When you go for split up marks, you will be reduced marks in each one of the case. Though you write all the questions very well, you will get reduced marks in this sense. It will be if you are writing all the sense, they will allocate you at least 7 marks here and 4 marks only here. So the loss of the marks is 2 marks for a single question, whereas here if you write all these terms well, the loss of mark will be only 1, that is 12 marks. Hope you understood the choice. Next is under April-May 19. April-May 19 they have asked one question based on that is first unit in terms of efficiency. So this problem I will work out for you. At that time I will explain you. If you know the question choices and equation part, you can attend this. So first, for this case of problems, you should be familiar with the equations related to it. So I will give a set of formulas to be studied for the all the units, and that will be posted in the next video. So next question they have asked is about FM superheterodyne receiver. So far you would have given importance to superheterodyne receiver term itself, that is AM superheterodyne receiver you might have studied. In that block diagram, FM superheterodyne receiver means you could study only AM superheterodyne receiver. Don't get confused. You should add only 2 blocks when they are asking for FM. In AM superheterodyne receiver, you could add only 2 blocks to make it as FM superheterodyne receiver. That block is nothing but a limiter as well as a de-emphasis circuit. So limiter and de-emphasis circuit is present in FM superheterodyne receiver. That is the only change you will find in FM superheterodyne receiver. So for that, if you have studied with AM superheterodyne receiver, go with all those points and only 2 blocks you need to explain further. Here also you should note only 7 marks is allocated for this question. So for 7 marks you could go with block diagram and write at least what that block explains about superheterodyne principle. That is enough for this. So you need not explain for a 13 mark question. So when you write this exam, you should plan and execute the you should execute your time management very well, else you will lose marks and in attending the part C questions or 5th unit question. So plan your time well and execute it. So for each question you should take at least 20 minutes. So at last I will tell you how you should manage this time. And the next question they are asking is here FM generation using direct method. This is also a very big question, but they have asked only for 6 marks. So when it is asked for 6 marks, you could go only with importantly you should draw with a block diagram. First give what is FM generation direct method, specifically what type you are going to explain. Write at least 2 sentences regarding this topic, then you go with the block diagram. Then you give some theoretical part what this block diagram explains, and that's how you could present the topic. Next is about FM deduction using PLL. As such, you write what is FM deduction and what is PLL in first 2 sentences. Then you start drawing of the diagram, this block diagram related with FM deduction using PLL, and explain what each block explains. So as a whole, for a 13 mark question you should write at least 4 to 5 pages. If your handwriting is in this way, you could write at least 4 pages. That is enough. If it is if you are writing close enough means in the same handwriting, if you are writing close enough means at least 3 pages for a 13 mark question is enough. Under unit 2, the questions they have asked is steps involved in PCM. So PCM encoder and decoder and expression for PCM SNR. So you should write what is PCM encoder and decoder, as well as you have to derive the SNR for PCM. This is asked in 13 mark question. And next is delta modulation. Delta modulation is asked in both the question papers in regulation 17, that is November December 18, as well as in April May 19 question paper. They have asked about delta modulation with quantization error. And next question they have asked is general time division multiplexing with its application in last year question paper, that is April May 19. Coming to the unit 3, the questions asked here are QPSK and DPSK under November December 18. They have asked either or choice, either QPSK or DPSK. And in April May 19 they have asked these 2 questions. It is binary phase shift keying, probability of error derivation. They haven't asked what is binary phase shift keying. Instead they have asked the derivation for the probability of error. So probability of error, in the case you should go with P of E, which is nothing but 1 by square root of E in terms of probability terms. And next is QAM. This is asked only for 5 marks. You should specifically read the question and then you should answer. They haven't asked what is QAM, fully the modulator and demodulator. They have asked only what is QAM modulation and draw the constellation diagram. For 5 marks it is enough to write only the 1 page in your university answer sheet. That is more than enough for 5 marks. Then coming to the fourth question, in the either or choice they have asked about BFSK. So BFSK in the sense binary phase shift keying and its probability of error derivation. So when talking about this BPSK and BFSK, they are relating it with probability of error derivation too. So read what is probability of error derivation also. So coming under fourth unit as we have said, it is all problem oriented. It is dealing with the Shannon-Fano coding, Huffman coding and some memoryless channel equations, etc. So this is the question they have asked. I will solve these questions in the next topics and I will post it. A source code has ABC symbols with probability of error. P of A is 1 by 2, P of B 1 by 4, P of C 1 by 4 and determine the source entropy. They have asked only what is H of S, not all the efficiency part. They have asked only H of S and this is only 4 mark question. So if they are giving 1 by 2 means you should use the calculator and calculate the value. It is nothing but 0.5. For 0.4 it is 0.25 and 0.4 it is 0.25. In this way, if they are giving in fractional value, you should calculate in terms of this integer value and you should convert it and then proceed with the following question. Next is find the entropy of a binary memoryless source and find when it is maximum. This is a short derivation part and coming under the unit 4 section. And next is explain Shannon's channel capacity theorem. It is also a derivation asked in under unit 4. And next question they have asked under November December. These three questions are asked in November December part. So either this half or this half. Next is a transmission channel as a bandwidth. This problem I will work out and let me explain you next in the next video. Next question they have asked is consider, it is April-May 19 paper. They have asked consider a binary memoryless source X with two symbols X1, X2 so that H of X is maximum when both are equiprobable. Equiprobable in the sense when they are equal, what is your H of S they have asked. H of S is nothing but your entropy. So for this case you should assume what is a probability case. If you assume the probability case as 0.5, then you should calculate what is your H of S. That is what they have asked and this is a 6 mark question. And next is a discrete memoryless source which is nothing but a Shannon-Fano code problem and they have along with it they have asked so that this code has an optimum probability when Ni is equal to I of Xi and its code efficiency as 100%. So this is nothing but you should find out what is code efficiency, whether it is achieving 100%. That is the question they have asked. Coming to the R choice, this question is nothing but about a convolution encoder. Find the impulse response of the encoder. So don't get confused. This impulse response is nothing but identifying your generator polynomial. So generator polynomial you should identify and that is what they have asked. So whenever a convolution encoder is problem is asked, most of the time the diagram will be like this and this is nothing but your flip-flops what I said. So if the connection is given to two modulo 2 adders, this V1 will have the output of this is connected with this 2. So I am taking here M1, M2, M3 means M1, M2 is connected whereas M3 is not connected. So it will be 1, 1, 0 case. For this case it is there is no connection 1, 0, 1. So this is how you should write the sequence generated in terms of the convolution encoder case. So for this I have executed one problem, so you could relate with it, and for the output code sequence you have to find out if the input code word is given. So it is nothing but all ones. At least you take 5 values of this, that is 1, 1, 1, 1 as sequence, because it is going on, because all the sequences are 1. Don't get confused. Write at least 4 to 5 sequences and you can proceed with the problem, and for this you will obtain a result. For that result you should write it as the answer in third column. So this is a simple problem. When you watch that convolution encoder problem, it is really very simple. And coming under fifth unit, it's a very easy unit and the direct questions are asked here. Either they will be asking about direct sequence spread spectrum or frequency hopping spread spectrum. In the November-December 18 paper, they have asked what is PN sequences and what are the properties. So you should observe what is the mark allocated for the question, and then for that you could write the answer. One, they have asked what is PN sequence and what are its properties. So PN sequence definition, it is carrying 2 marks. Properties naming, it is 3 properties it has. It is allocated with 4 marks. And what is the difference between frequency hopping spread spectrum and direct sequence spread spectrum is asked for 4 marks. I write at least 4 points. And what are the advantages of spread spectrum? They have asked allocated 5 marks. Write at least 6 points. That is, if it is 5 marks, write at least 1 point extra to get at least full marks. Next is in the next question, in our part, they have asked about various multiple access techniques with advantages and disadvantages. Whenever under this 5th unit, they are more particular about the advantages and disadvantages. So for all the cases, you should know what is the advantage and disadvantages of the spread spectrum, of the frequency hopping and time division multiple access, frequency division multiple access, or code division multiple access. Next is frequency hopping spread spectrum comparison in terms of fast and slow is asked in April-May 19, and about TDMA and FDMA with its advantages and disadvantages is asked in April-May 19. Under part C, November-December 18, it is a theoretical question, whereas in April-May 19 it is fully analytical part. It is a very big question, and it is asked as a problem, that is, it is asked as a problem. So let me explain you in the next video of solving all those problems with the formulas what you should study to solve any type of problems I will give you. So under part C, modulation techniques used for television signal is asked. So television, if you see the name television, it is nothing but vestigial sideband. Whenever you see the word television, you write about vestigial sideband. It is allocated 15 marks. And next is superheterodyne receiver, which is asked in terms of sensitivity, selectivity and image signal. So superheterodyne receiver, they haven't specified what type, so you could go with any type of the superheterodyne receiver you know. Under part C, another 2 questions under April-May 19 is nothing but a big question, which is a problem one. We'll see it in the forthcoming classes. So for your understanding, I am just showing you the question asked in part C, April-May 2019 arrear paper. So this is the question asked. This is nothing but which comes under 2nd unit. Very big question, but solving purpose it is very easy if you understand the question what they have asked. And next question they are asked is either or choice, also they have gone with one problem. So this is also a big problem which can be solved easily if you know the question, if you understand the question. So all the very best for your exams. Using this questions you could study.